Okay, so let's take a look at problem 5 from the homework quiz. So this one involves using Euler's method to solve a specific differential equation. So in this problem, the usual way to approach Euler's method is we make our table. So let's see, the information that we'd like to know is what's the value of k, what's the value of x sub k, what is our y sub k, what is our slope or y sub k prime, and then what is our new y sub k value. Okay, so I guess I'll want probably one more row in this. So when k is equal to 0, we get x0 from our initial condition. The initial x value was 1. Our initial y value was -2. So to find y0 prime, what do we have to do? Well, we plug in 1 and -2 to this formula, and we get that it's equal to -4. So that means that y1 is equal to y0 plus y0 prime times delta x. So y0 was -2, y0 prime was -4. So we multiply -4 by delta x, we get -2. So overall we get -4 for our next y value. So now when k is equal to 1, x is increased by delta x, so we're up to 1.5 here. We know that yk, by carrying down from here, is -4. Let's calculate what is y1 prime. Well, by plugging into our formula for the derivative, we have that it's 2 times 1.5 times -4, which is 3 times -4, -12. And that means that y2 is equal to, let's see, we're going to have y1 plus y1 prime delta x. So y1 was -4, and we add half of delta or half of y1 prime, which is -6. So overall we get -10. So if we fill in our table here, we now notice that what we were asked to do is find the value of y at x equals 2. We see that once we reach k equals 2, x has reached 2, and our y value is -10. So our conclusion is that y of 2 is approximately equal to -10.